Okay, so this next lesson we're going to practice multiplying polynomials again. However, we want to recognize some patterns after we multiply binomials. So there are 4 examples shown here, and I want you to recognize what's the same about them, what's different about them, and I would like for everyone to write down these 4 problems and to multiply these expressions, and then ask yourself, what do you recognize about the products? So what do you recognize about your final answer after you multiply? And now, after you write these down, make sure that you're utilizing the FOIL method in multiplying these binomials. So pause the video and attempt to complete these 4 problems. Okay, so I'm going to go through and I'm going to multiply them as you all have done. So I have x squared plus 2x, and then I have plus 3x plus 6, which then turns into x squared plus 5x plus 6. Okay, how'd you do? Now let's do the next one. And I'm going to draw the arrows with my pencil. I'm not going to actually draw them on there. So I have x times x, which is x squared, x times -2, 3 times x, and 3 times -2. So when we combine like terms, we get x squared plus x minus 6 for this one. All right, for the third one, we got x squared, and when we multiply our outer terms, we get plus 2. X minus 3x minus 6. And then this turns into, after we combine like terms, x squared minus x minus 6. And then finally, we get x squared minus 2x minus 3x plus 6. And when we end up with x squared minus 5x plus 6. So now we're looking at all 4 of these products. So what do you notice? Are the first terms all the same? They are. So what's the same about all of these? Why are these all x squared? So everyone has to think of something in their head, but if you notice that we have x times x is always our first thing that we're multiplying. And now, what about the last term? What do you notice about the last term? Right, they're all 6, but these two, the first and last, are plus 6, and then the middle ones are minus 6. So let's see what is happening inside of those products, of the factors. So for this first one to be plus 6, we have plus 3 and positive 2. In the second one, we have positive 3 and -2, -3 and positive 2, and then -3 and -2. So notice how the signs are the same in these factors. So the signs, the plus and the plus. Just going to circle these guys for a minute. So when the signs are the same, when they're both minus and both plus, notice how this last term is positive. And then when the signs are different, so notice that we have positive 3 and -2, and then -3 and positive 2, we have our last term is negative and -6. Okay. And now if we look at the middle term that we have a 5x here and a -5x there. So what is positive 3 plus positive 2? Is it 5? Look at that. And how about -3 and -2? When you add those together, do you get -5x or -5? You do. And now what if we added these other two? right? We have positive 3 and negative 2. So positive 3 minus 2, do you get positive 1? You do. And if we have negative 3 and positive 2 and you add those, you get negative 1. So I'm wanting you to check out some of these patterns when you're multiplying these binomials and see what you can conclude before you even multiply them. So now I'm going to ask what a factor is. And the factors were what we multiplied. So the terms that you multiply. And the final answer for a multiplication problem is a product. Okay, so we're going to begin utilizing these terms to help us now. So if we are looking at these 3 examples, I want us to look at this first one and think about what we had to do. We could use our exponent properties, but when we derived our exponent properties, we expanded 4x into 4x times 4x. So now we have 16x squared. So these are called your factors. And then the 16x squared is your product. So let's use that same idea. So if we have 4x squared, that was 4x times 4x, but now I have x plus 4 squared. So x plus 4 times x plus 4. When you see a binomial squared, you must expand. Expand, expand, expand. So when you expand, notice how you have x plus 4 times x plus 4. So these are your factors. And when you multiply them, you use what method? You can use the FOIL method like you practiced last night for homework. So when you multiply your first terms, you get x squared, outer terms plus 4x, inner terms plus 4x, last terms plus 16. So x squared plus 8x plus 16. And this answer is called a product. And the product is a trinomial. So for this last one, what do you suspect we have to do? If you see the x minus 4 being squared, and if you said expand, you are correct. So why don't you pause and multiply that? So when you answer this, we get x squared minus 8x plus 16. Again, we have a product, so these are products. And these are factors. Okay, so now I'm wanting us to multiply x plus 5 and x minus 5. So we have the same first terms, same last terms, but notice how the signs are different. So when we multiply the first terms, we get x squared, outer terms minus 5x, inner terms plus 5x, and last terms minus 25. And notice what happens when you combine like terms. These middle terms go away, and you are left with, go away as in cancel out, but now you're left with a product that is a binomial. So your factors were binomials. Each of these were your factors. And then when you multiply them, it gives you your product. So it's kind of nice because these middle terms cancel out. And let's keep seeing what happens. So let's try these next two. So if we multiply our first terms, we get x squared, outer terms plus 6x, inner terms minus 6x, last term's minus 36. So what happens to those middle terms again? They cancel out. And now, again, we're left with x squared minus 36. So let's look at these first two. We had 5 and 5, and we got 25. And then for the second one, we had 6 times 6, and we got 36. And again, we had x's, and we had the same number. So could we jump right to our product if we recognize that same pattern in this third problem? So we can always multiply out and use the FOIL method and then reduce like we did in the previous ones, or we can recognize that it's going to be a special binomial product and multiply our first terms and our last terms and jump ahead and create a shortcut for ourselves. So if we wanted to do, if we recognize that same pattern here, we have our first terms are the same, our last terms are the same, and are the signs different? Sure. So what if we multiplied our first terms and then multiplied our last terms? Get 9x squared minus 16. And if you don't believe me, you can always multiply it out until you see the pattern. And this pattern you don't have to use, but it may be helpful. So that's the end of these notes today. Make sure that when you are multiplying, you can recognize the patterns. And then also, we have to remember to expand when we're squaring binomials.